questions and people pop things in, please don't hesitate to interrupt me. I generally get distracted and just start.
I'll keep an eye on the chat. We try to do Q&A at the end, generally let you find your flow with the presentation, but I'll keep an eye if there's some clarifications people want on something you're saying, I'll jump in.
Yeah, perfect. Because this isn't so much of a cohesive presentation as a bunch of odd little pieces of stuff. So I don't mind stopping and talking because there's a ample room to chit chat. I have no idea how long this is. So I'll go through and figure it out as we go. So get that working. There we go. So here's what you're in for tonight. Talk a little bit about how and why I got here, some conversations with some folks on the leadership team with some stuff I was doing, and there seemed to be some interest in some of the technologies. So I'm going to tell you a little bit about the project I'm working on and how I'm using the technology, because it kind of sets the stage for what I'm talking about. Talk a little bit about restful tricks in .NET, which is really nothing more than just some of the basic ASP.NET Web API stuff, and specifically some stuff I did for the first time the right way on this project using Patch, and kind of made me happy. So I wanted to talk about that, something I'm definitely going to do more of. Then I'm going to talk a little bit about deploying .NET on AWS, specifically lambdas and ASP.NET and how they play together. Talk about API management and how I use that to streamline some deployment and development things that I found pretty handy. Cloudfront as well, because yeah, your mind changes and I never make up mine. So Cloudfront was nice to have there to be able to switch stuff around for the way I deploy my application. And then lastly, shared load balancers, which a lot of people don't know exist on AWS, but they're kind of a big deal because they save you a lot of money and they're pretty fun to play with, and they play together nicely with all those technologies that I mentioned. So who is this targeting? AWS developers who might need to integrate .NET and don't know where to start. .NET devs interested in AWS. Folks with nothing better to do on a Thursday evening, I suppose, as well. This presentation assumes a basic understanding of AWS, .NET, networking, and web architecture. So hopefully I hit the right level for that. I like to stop, now that you guys know that I'm talking about this stuff. Is there anything in particular that you guys want me to focus on or go into a little deeper, or what floats your fancy? Any thoughts before I get going?
I mean, I would float something out there just for context, since I have a little bit of AWS and I have C# not in a .NET context. So I'm curious why AWS with .NET as opposed to .NET Azure, and maybe you can kind of lay out some of those choices along the way.
Yeah, great question. Okay, anyone else?
Yeah, so I'd be interested in knowing one of the issues with serverless and AWS has been cold start times in some languages. So I'd love to know kind of, this is going to be like super deep, right? But like if you happen to know like on a VM level, like kind of what the network performance is of .NET compared to other languages in serverless, and are there any like workarounds you have to do for some cold start issues?
Yeah, cold starts suck. I'm still looking for a language that doesn't have cold start issues, but yes, we can talk about that. That's definitely, it's a what it boils down to is it's a showstopper for serverless in many instances, and I'll talk about how I worked around that. But the short answer to your question is serverless doesn't really work if a user is tied to that service, is my conclusion. But that doesn't mean that it's not very useful in the stack. But it's a great question. I'm going to disappoint you and not give you the magic answer, but it's kind of at the heart of what I'll talk about. So that's awesome. And then to Bradley's question, one of the biggest reasons this is on AWS is because I needed to get experience on AWS. So when I started this project, that was one of my goals, was to teach myself the AWS stack, having more familiarity with the Azure stack. And so I went kind of the full Monty into the AWS stack. So again, to disappoint you maybe on a technical level, a lot of this is just because this is stuff that I needed to add to my skill set. That's a big part of it. And the .NET part of it is because while I'm learning AWS, I couldn't learn everything at once. And so .NET's kind of my comfort zone. So I didn't want to change everything all at once. So I stuck with .NET AWS as a compromise. That's actually a really important thing to understand because there is no reason other than that any of this is on AWS. I generally like AWS better than Azure. In some ways, you have more control, you have more granularity. You can flip more switches, but Azure sure is nice when you just want to get up stuff quickly and not have to worry about some of the plumbing. Anyway, just my 2 cents. So about me, I think Bradley summed it up. Yeah, I've been doing this a long time. I have a degree in abacus science. I remember next generation Windows services. Anybody else does? Can you tell me what they are? Anybody?
Are we talking about like stuff that came out in NT4 or?
You're getting close. Yeah, next generation Windows services was .NET before it was .NET. And that's actually when I started working with .NET, which is frightening. Anyway, so that's me. So Music Nest. So Music Nest IO is a project that I'm working on now. It's a startup, very much getting off the ground. We've got a few pilot users, but hitting hurdles daily in terms of getting more people on board. I'm not going to give you my formal boring pitch, but on the high level, any of you who have ever studied a musical instrument, there's a methodology of teaching called Suzuki, which basically is letting a student listen and hear music and replicate it. So children learn things in ways that adults can't. If you've ever met somebody who grew up speaking 2 languages and been in awe of the way that they just naturally think in multiple languages, and if you've tried to learn a language as an adult, you realize that there's a depth to your brain their brain that you will never have. So the theory is that by listening and replicating music, learning sounds and replicating the sounds, learning the scales more of in an emotional way versus reading notes on a page, it gives somebody a young adult, a young music student, an understanding of music that you just can't get once you pass a certain age. I can tell you that I witnessed my son go through this and it was magical. It's one of the things that inspired me to work on this project. One of the core problems with that, though, is that the technology of giving dynamic playlists to your students based on where they are in their musical journey is actually really hard. Technologies and sharing playlists and Google Drive and Dropbox and all these things are very cumbersome. And as a result, it's kind of a common thing that we've learned in the music community that students just don't listen enough to what they're trying to learn. Any given time, you're learning 1 or 2 songs. The idea is that you would be listening to those songs 3 or 4 times more often than you're playing them, and your fingers learn to replicate them. So the system that I'm working on basically allows you, starting left to right, you manage your schedule. So when the instructor pops in, they say, okay, I got Jimi Hendrix at 10:15 a.m. Click on them. You can go into the list of songs that they're working on, very easily drag and drop songs into the list. It's actually not the right screenshot, so don't get too caught up in that. And then a link gets sent out to that student. So Jimmy gets a text on his phone that gives him a hyperlink, which launches a player, standard web player, which basically allows him to hit play when he's, when his mom's driving the car to listen to the music that he's learning. So basically it connects the actual set of songs the student's learning at a given time dynamically per student to a playlist effectively that just, you can put your headphones on and listen to music. That's fundamentally what the system does. So, do you need something? I'm in the middle of a presentation. Thank you, Noah. That's Noah. That's the inspiration behind Music Nest.
Hi.
Sorry about that. All right. So
Good context. Good context.
Yeah, you can play. He'll play a song for you at the end. So let me close this. So let's geek out. So no more business boring stuff. I'm just going to dive into some code and talk about how I built what I built. One of my favorite quotes, the code I will write in 5 years will make the code I wrote today look like the code I wrote 5 years ago. So it's all a journey, and it's always amazing to me how when I look back on code I wrote a while ago, how crappy it is. So anyway, fun quote. So here's the stack of what I'm using for the system. The front end is Xamarin and Angular. There's basically two applications: a Studio app, which is what the instructors use to edit and manage the students and the songs and all that kind of stuff. Then there's a listener app, which is what the students get to listen, and then also eventually get notes and things from the instructor and do some other fun stuff soon. The front end uses Cloudfront, Amazon API Gateway, and Amazon Load Balancer. Kind of 3 levels of things that allow me the flexibility I need to deploy in various ways. Using Cognito for authentication. In the middle end, we're using basically lambdas and beanstalks on top of web APIs. So all .NET web API code, some running in lambdas and some running in beanstalks. Eventually, I want to migrate the beanstalk stuff over to Fargate, but haven't gotten there yet. All the events are just basically simple stuff triggered off SQS to lambdas. On the back end, we have DynamoDB, Amazon. S3 is basically the 2 repositories. I'm expanding that, but those are currently what I'm using for most everything. From a code perspective, it's mostly C#. A lot of my lambdas, the one-off lambdas are written in Node.js, and I think there's one that used Go just because, Jeff wouldn't let me present unless I had the Go icon in my presentation. So, microservice. So first of all, from an application standpoint, I don't know what the hell is happening with my dog. Hey, can we? Oh, sorry. All right. Thought my dog was being tortured. So microservices is kind of the foundation for how I break apart my application. Microservices, of course, is one of those terms that's thrown around and doesn't really mean a lot. In my world, I basically just break out my application into sort of logical pieces, authentication / studio management, creating a new studio, all the authentication, studio membership, students, all that kind of stuff. That's a second microservice. Library, the managing of the songs and the learning assets, and lastly, listening. You combine the studio membership with the library, you generate some listening resources that is the fourth microservice. All of those sit on top of the same set of repositories. It's not a perfectly clean microservice system, but it's pretty well broken apart. I like it because it allows me to develop quickly, promote smart lines of separation. It's very testable, which is important to me, and it allows me to do small, safe updates, so I don't have to update the whole system when I make a change here. So I use CloudFormation to deploy the microservices. So in a nutshell, each microservice is a CloudFormation template. That's partly a lie, but mostly true. I use API Gateway to aggregate the microservices into a clean, kind of cohesive API. And then each microservice I kind of think about as just a small little RESTful service that exposes a series of domain objects, which really amounts to the way I built my system. So that's my high-level architecture. So now ASP.Core Web API, just talk a little bit about what that is. This is really, it's funny, I was showing Jeff some code and I just assumed he understood when I said what this was, what it was, but he didn't until I dove into the code. So I decided to just explain to you, this is really pretty simple stuff. All you're doing with the web API is basically defining your routes. So you have your controller. So this would be, your root path library / the path is knowledge categories. So in a URL standpoint, it would be HTTP using nest.io/API/library/ knowledge categories. And this would be the post. This would be the put. This would be the patch. This would be the delete. So basically all web API is giving me is a nice clean set of endpoints for my domain objects. Really nothing more. Behind this, you have all your standard business logic. So I have a class library that implements my repository or does whatever the heck it does. But in a nutshell, the web API is basically just wrapping all that functionality into a RESTful API. So each of these microservices that I mentioned up here is effectively just a set of domain objects exposed over a RESTful API. That's really all I mean when I say microservices. Behind the scenes, of course, there's events, there's things that get triggered when certain things get updated. It gets complicated, of course, but for the most part, that's how I break things out. Lots of people have different definitions for RESTful APIs. I kind of think about it this way, just to keep myself sane. A GET is cacheable stuff. It's global stuff. It's stuff that doesn't change very often, that you can, expose to every client. A POST is specific stuff. So if you're doing a search and you're saying, give me a list of songs for this studio with a set of filterable options, it's just a POST to get resources that are specific to a certain context. A PUT is where you're putting new stuff in the database, and a patch is where you're updating stuff. Really, 90% of what I do is broken into those four things in a RESTful API. So the only one that I think probably is of interest there is the patch. I've not run across very many people that use patch. I've not formalized my patches in the past, and this time I decided to, and I gotta say I'm not going back. So just to kind of update you, a patch is basically, you have a document, you have a patch structure, so you have your array of operations. So the operation here is replace path BAZ with the value boo. So as you see here, the baz goes to boo. You can replace, you can add, you can remove, you can test. There's a set of operations, things you're applying to an object. It's all a patch is. And what does this look like in code? So the reason I like this, but I think this was a big win for me on this. As I'm building out APIs, the thing that I never know is what bits of information I'm going to update when and with what other bits. And the nice thing about the patch structure is that once you have it in place, once your app is sending a patch structure, you can change what bits of information get updated without having to rewrite everything and rewire your plumbing and add new routes and add new paths and all that kind of stuff. So once that's in place, you can send any combination of bits and bytes without having to send the whole object or anything. I do implement a concurrency model in that. So every object has a revision. I call it a revision, which is basically just an integer that's unique to that instance. So I in every patch function, I make sure that there's a test that includes the concurrency stamp. In my case, it's revision. So if you send an object that doesn't have the revision, it basically doesn't allow it to be updated. So you can't make mistakes. Then if you follow through to the actual patch implementation for, in this case, the library, the first thing you do is you go out and you get the category. I map it to my domain object. So I map it from my document language to my model language. Then I call this magic.net method called patch request.apply, which basically takes this magic structure called the JSON patch document. Nothing specific to .NET here. It's a .NET implementation of the JSON patch paradigm. So I get my object, I call apply, and then basically I upsert it back. So this would be the equivalent of sending the entire object and doing a put with an upsert. The nice thing about this is that this code is horrible because I don't want to have to pull my object back, do an update, and send the whole object back to my NoSQL repository. Eventually, I'm going to change all this code out to just do an update. So in a SQL world, you'd say update category where revision equals 5. And if that update returns a 1, it means you got a successful transaction. In the same way in your NoSQL world, you set your criteria and you do the update without having to pull the object back. This is just a real easy way to get up and going quick, because as we all know, in a startup, you're trying to get things done quick. So what I like about the structure is the patch allows you to have really endless flexibility, implement it very simply out of the gate, but you kind of leave yourself all the room down the road to make it much slicker and faster and cooler. So that is my patch goodness. Questions. I'll ask questions on that before I move on to some of the .NET deployment and AWS stuff.
There's a couple questions in the chat here, Dave. The
yeah.
first one, Andre Andrews would like to know how you dealt with Digital Millennium Copyright Act or digital rights for sharing songs, noting it's a headache on Apple.
Yes, I don't. I punt. So the model that Music Nest incorporates is that when you're uploading an audio asset, it's your asset. So our instructors are recording their own audio of the songs they're teaching to get around that, and most of it is in the
Fair use, right?
Not open source. There's a word for open source in the real world. What's that?
Public domain.
Yeah, most of the stuff. So Twinkle Twinkle Little Star, you can record that and distribute it. There's some business model interesting possibilities that combine some stuff there that we haven't made any progress on yet. But right now the model is basically, you're sharing stuff with your students that you've recorded yourself or you've bought from somewhere that you have the right to distribute. Cognito, how's your experience with Cognito in terms of scoping permissions, user management, and speed of development? So if you're doing something very simple in Cognito, it's great. All their out of the box, create a user, update a user, all that kind of stuff just kind of works. It's generally kind of ugly and clunky, but it works. I didn't use it because the experience for signing up was a little more custom. But I found it to be pretty easy to work with and pretty smooth. I don't know. I think the biggest benefit is that when you're doing stuff on AWS, everything integrates very well and seamlessly with Cognito. So the biggest advantage is if you're on AWS, everything plays nice together. But I wouldn't necessarily give it kudos or props over other services, but it's more than good enough for what you need.
I've got a question, and Adam may have a question for you on Patch as well. But earlier in your stack, I noticed you were combining Angular with Xamarin. Did I get that right?
No. So we have no. So right now everything's in Angular. I've deployed a couple Xamarin. So the eventual web listener is going to be replaced by an app, and I'm torn between not going Xamarin or going Xamarin. I've kind of done both, and I haven't decided yet. Honestly, the web player is working well enough that I hadn't had to make that final decision. But
yeah, can you unpack that for a second? When you think about going Xamarin, certainly there's flexibility there. What's your hesitation, or what don't you want to open up in that?
So not going Xamarin is nice because I can reuse all the maybe just package up what I have now into PWA or reuse all the JavaScript, reuse all the code as much as possible. The Xamarin UI is just kind of fundamentally different. The biggest thing about Xamarin is that I people don't like to talk about Windows clients, but the Windows client thing for me is very important because a lot of people are running at home a native Windows client. So that's really the biggest draw for Xamarin. If we decide that that's not important, I probably won't go the Xamarin route. The music industry is very much an Apple industry, but the user base is very much a normal world. So we've actually had a lot of long discussions about what's worth it and not. Yeah, I don't know. I have a lot of Xamarin code that I'd like to reuse, and I'm very comfortable in that world. So I don't know. I don't know that I have anything intelligent to say past. It's really more of a curiosity in what I decide is the most important client experience.
Yeah, I mean, it was fascinating when I saw that. I sort of did a double take because, back when I was working on a list-based mobile app, Xamarin Forms had just gotten stable, relatively stable. And so I think, oftentimes Xamarin and Xamarin Forms get conflated. But certainly sort of the stuff that you're looking at kind of lends itself to universal UI like Xamarin Forms would offer. And I was just kind of curious around some of the thinking in that.
Yeah, it's really more of a question of reuse than, I mean, I think it can go either route. I had a whole bunch of Windows code, and it just didn't play nice in the browser. So I switched and went the Angular route to kind of fix some deployment issues without having to build a full-on app deployment. And that's kind of why I went the Angular route after starting out in a Xamarin world. But yeah, it's kind of a mess if I'm honest. But right now, I think the answer is probably keep the web client Angular and then build out the very streamlined web listener as a Xamarin application. That's where my head is right now. It's super thin. In fact, 9 out of 10 Xamarin demos you find are web media players. So I'll probably just steal one and run with it at some point.
Any other questions in the chat as well? And by all means, go on, Dave, if you've got more to unpack about that as well. Just want to make sure people have a chance to ask what they want to ask.
Yeah. So that's Patch. I mean, that's really the only thing I think I've done interesting on the C# side that's kind of made me happy and wanted to share. So .NET and AWS.
I'll say, Dave, real quick before you go into this. I actually had a couple questions on Patch. So I've done a lot of RESTful API development over the last, 5 years. And we've always used puts. So you essentially get your object with a network request, do the changes you want, and then do a put back. This is frankly the first time I've ever seen Patch used. So very interested in the design pattern here. What shortcomings have you noticed in this? Or like, as someone who wants to take this talk and start playing around with using Patch now, like what should I be looking at in terms of shortcomings or things to know about?
So what you just said is exactly where I was when I started this project. I had always kind of had a hodgepodge of stuff and really that you kind of hit the nail on the head in terms of the problem that always bothered me. Like I have my client, if I want to send an update, I have to have all the methods there to be able to send back this kind of cohesive object so I know I'm not overwriting stuff. And there's a whole bunch of concurrency issues that came up with that. And part of it was just kind of intellectual curiosity of just not being happy with always having to have the whole object go over the wire. So I poking around and I stumbled across the patch structure. And I mean, really, it's, all you're doing is basically sending a list of changes to the server. So the shortcoming is that you have to track that on the client. Let me see if I can show. I'm going to show some code. This is this is the Angular code. I think I can show you something if I can find it real quick.
And I guess while you're looking at this, the question I kind of have is specific. I guess a specific use case here of how do you deal with I want to patch something by basically removing a property. I want to set it to null, for example. How does that kind of work with a patch sort of mentality versus a put mentality?
Yeah. So I mean, the only difference between a put and a patch is that a patch you're giving a list of operations to apply to an object, and in a put you're sending a copy of the object that you want to replace. So the challenge is you've got to track the list of properties that you want to update. So there are a whole bunch of JavaScript patch libraries out there. None of them kind of just worked as easily as I thought, so I just rolled my own. I created this thing called a patch tracker. This is, don't judge me here, but this works. Basically, you have a bunch of methods where you set an operation, you set a test, you set a replace. So again, a patch has a replace, an add, a remove. So you can say I want to replace this value with that value. Again, you can replace this value with that value. You can add something to if you have a list as part of your object, you can add an element onto the list, or you can remove. In this case, you remove the property called foo. Removing a property and sending it to, and updating with a null, kind of the same thing, but different, depends how you define it. So the hard part is that basically you have to track the patch operation. So I created just this little hokey structure that tracks operations. What this looks like in code, if I can find one real quick for you. So that's not going to do it. Hold on. So basically, whenever trying to tie this together, what it all looks like. I'm sorry, wasn't ready to do this.
That's okay. Take your time. Live demos are always great.
Yeah. So here, basically, the UI. So let me see if I can show you this list. So this is do I have it running? This is going to make my presentation longer, but it'll be more interesting for some, I suppose. So this is good. So if I bring my app in here, so I go in here and I say listen list, right? Here's a listen list for this, and I want to change this value to, I want to drag lightly row above twinkle twinkle, right? So what that amounts to is this method here gets called where I'm basically patching a new array. I'm basically saying I want to update the knowledge identifiers property of the listen list to this new array. And what that ends up doing is going to this patch structure, and it replaces the path, so that's the name of the parameter that was passed in, with the value. And so in code, that basically would be this, replaces this value with that. That gets sent over to, that gets sent over to the server, right? So this is the endpoint on the web API that takes that patch document. So it's just a list of operations that are typed to the knowledge category object, validates that it sent the concurrency stamp, which in my case is revision. I just make sure that revision's there so that it doesn't, I actually check it again downstream, but this just makes sure that I don't do anything dumb. Then I actually call my repository method, which is the patch method in my library cloud, because I'm cool, and I call it a cloud, which comes over here and then just gets the object. So in a patch model, you would basically, you said it, you'd have to have a copy of the object at the client, you'd apply your update and then send the whole object back. That's effectively what I'm doing on the server side. I'm getting the object from the repository, I'm mapping it to my domain language from my document language, and then I apply the patch, which is the magic. So this is kind of the magic piece that the C# library does for me. It basically takes this patch structure and applies it to the object. So it does all that hocus pocus magic, and then I just upsert it back to the repository. Now, that's great because it allows me to move very fast, and I can write one function. I can change my UI around, and I can update things in different orders and different sets, and I basically just send the same structure back as long as I'm talking about a domain object of a listen list, and it updates it without me having to write code for any permutation that I want to do. The thing that I don't like about this is I still don't like the fact that I have to pull the object back. So in a SQL world, if you're updating a name property, you can say update object set name equals Joe, where revision equals 2, right? And you don't need to make the round trip to the database by pulling the object back. You can do the same thing in a no SQL world, of course. But the idea is that this code was really easy to write quickly and kind of get the functionality up and working with very little effort. But I have the freedom, since it's all server side, to optimize this down the road and make this much more efficient and smarter. Like in this case, this is an event-driven system. So if the published date of that library, I'll spare you what that means. But if the published date of that library changes, then in addition to updating the object, I also publish a value to the library queue, which triggers an event which does a bunch of updating asynchronously. So this is an example of where I take the patch structure. This isn't the prettiest code in the world, but it really gives me a tremendous amount of flexibility to do what I need to do because I know exactly what changed. Whereas a put is basically the same thing conceptually, except you have to know what the object is before you even decide to update it. Did I answer your question?
Yeah, that definitely helped me understand a lot more. When it comes to kind of like low, well, like slow network issues, right? So like you have this revision path, which makes me think you're kind of using it like a nonce. right? So like you would have to wait for a response back from the server before I send another patch command, right? Because because I have to be applied in order, right? And I have to have, as a client, I have to have confirmation that it's been applied before I send the next command, right?
Yes.
Okay.
And so the patch operation this patch structure handles that. So it uses, first of all, it debounces it. And then second of all, it basically acts as a semaphore. So when an update's happening, it's stacking up the updates. When the previous one comes back, it gets the latest revision. So actually the only thing that's sent back is the latest revision. And then it sends the next update when that debounce time's out. So it's like real-time updating that sends an update when the user hasn't done anything for 2 seconds, but it queues up updates behind, if that makes sense.
Gotcha. Okay. Yeah. So you're basically, then you could optimize your network calls based on flushing a queue out to the network and like stacking all the commands.
Effectively, yeah. The other thing you can do is I'm using this concurrency stamp, right? Because that's just how I built it. So I need that concurrency stamp back, but this test, where is it? This test, so there's an operation called test. I use it here to show you like operation test path revision, but you can also, your test doesn't have to be a concurrency stamp. Your test can be the previous value. So if you update name from Joe to Sally, you can add a test operation that says only update this if the existing name is Joe. So update to Sally, but only if the previous name is Joe. In that world, as long as you're sending them sequentially, you don't have to wait for anything. So you can use the operations in whatever way makes sense for what you need to do. And I guess that's what made me happy about this structure, is that it just really gives me heaps of flexibility in terms of how I want to update stuff. Because that's the one thing that's always frustrated me. Like as you're building out these APIs, the order the user is doing things changes every time you talk to a client or every time you talk to a user. So once I went to the brain damage of putting that patch structure in place, I was kind of freed up on the UI side to just make changes without having to rewire the plumbing.
Am I understanding right then that you're conditionalizing those updates then? So essentially you don't have to worry as much about asynchronicity, or is that a different issue?
Yes, yeah, that's one way of looking at it. I mean, I look at it from a concurrency standpoint that I want to make sure when I update this object, I know the starting point for that object. And you have control over whatever criteria you would want to set for that test. Test is one of the patch operations. So you can say, when you submit a patch operation, you can say, include a test as part of this patch, which basically is saying, if this criteria is not true, then don't do the update. But you can implement that however you want. I implement it with a concurrency model, and I queue it up with just a simple, reactive type pipe. So that's all. Yeah, and the real win. I mean, the real win is when you're in the throes of building your UI and moving this piece here and this piece up there, you're completely freed up. You don't have to think about how you're updating the data. And so the real benefit to me was once I had that infrastructure in place, all of a sudden building this UI out was just super easy and super, super flexible. So as I went through various forms and whatnot, like it allowed the development to go much, much faster. So like
Great.
all this dragging and whatnot.
We're coming up closer to the end. Adam, did you still want to ask your question about Cognito? Was that relevant?
We already got that answer, but Dave, thank you very much for going through the patch here. This has been awesome.
Yeah. So I'm out of time.
I mean, we can continue. We go till I think 8 o'clock, right, Arsh?
Okay.
So by all means, if you're able to stick around, I also understand you have a family too. So feel free to drop off if you need to.
Yeah, no, I'm happy to. I mean, here's what I was going to talk about. The AWS side of that, but probably don't have time. So one thing I definitely want to bring up here.
I would vote to keep going forward, but that's my vote.
Yeah, you got an audience. It's COVID and it's a Thursday night, Dave. So by all means, continue if you've got more for us. And
Okay.
No one will feel bad if anybody wants to drop off as they need to.
Yeah, no, cool. That was fun. I mean, the patch was one of the more interesting things. So it's super curious that that's what got your attention. And I'm happy to have explained this. So basically, I'll go through this quick. So Lambda Web API wrapper. Basically, when you build your Web API. Your Web API is just a project in C# that implements a RESTful service, and that's what this Studio's API is. This is just your standard web service. You deploy that to Beanstalk, point a URL at it, and you can rest until you're restless. Haha. What you do is you basically wrap. What I do is I wrap the API with a serverless Lambda, and you can think of it as just basically some glue code that takes a web request and passes it to your web API. So you can deploy your entire RESTful service as a Lambda. Super easy. It just works. Cold start sucks. So to answer somebody's question, it just does not work in any model where you have to have any kind of user interactivity with that service. It's too slow. I tried every permutation of trying to keep a provision count. It just doesn't matter and especially in this world, even on top of all the usual cold start issues, you also have to spin up your website for each and every request. So you have to go through your whole startup routine, initialize your dependency injection, all that. So it's not a really reliable option for any kind of interactivity. But the same code basically can deploy to many platforms. So Lambda, Beanstalk, and Fargate, all the same package in different forms. API Gateway. What's the familiarity level on API Gateway with the group? Like, does everybody know how it works? Okay.
I think it's probably pretty varied, so feel free to explain.
Yeah, so an API gateway is basically just a way of aggregating methods behind a unified URL. So this is the definition I stole off of WikiLeaks. So you can kind of read this, and it kind of gives you the academic view on it. My take on it is basically that it allows me to take my microservices and aggregate them together into a cohesive API. So I have all my services, which are all RESTful which are all independently compiled RESTful services, but I can pull them together on the front side, one common API, offload authorization, API keys, throttling, all that fun stuff, without having to do much thinking. What this ends up looking like, so here's your API. So this is your V1, which is your top route for your path. Then I have my auth microservice, my listener microservice, and my studios. Each one of these just maps to what's called an HTTP proxy, which is basically pointing to an individual version of one of those microservices. In production, I'm using Beanstalk because cold starts just don't work. And then Lambda for staging, which is awesome because I can run staging without any costs. I can develop off of like these 3 microservices up there in AWS, and then one of them running locally on my machine. So it gives me a lot of options. In an API gateway, you can have stages. So you have like a dev stage, a prod stage, and each of these point to different URLs, different root URLs off the core. So it allows you to have multiple versions of API running at any point in time. And you accomplish this by each of these stage variables for each of the microservices points to its own URL. So effectively, you're aggregating multiple web-based services in one cohesive API that your application can just talk to one endpoint. And again, the nice thing is, in my world, we have production staging, one using serverless, one using not, because functionally serverless works great, but it's too slow. So in production, I point it to an exact replica in Beanstalk. API gateway, is it worth it? Yes, I think so, but it's definitely a heavy lift to get up and going. Once it's in place, it just gives you a lot of flexibility for deployment. But I don't think it's an endpoint. I use Cloudfront for the front end. So you can think of the web API as aggregating the API management that aggregates your microservices, but CloudFront I use to aggregate my application services. So like my media assets, my API, and then my SPA assets are all behind a CloudFront deployment. So yeah, what's important here? Origins and behaviors in CloudFront. So an origin is basically like, so for example, this is an S3 bucket that has all my media assets, and this one here is my API. So I can take one URL and have the API aspect go to the API gateway, and then the SPA asset go to different places. So what this all ends up looking like, yeah, then I did this load balancer. I'm gonna blitz through this. So yeah, CloudFront aggregates your application, API gateway, aggregates your API and your microservices. Last thing that was interesting was the shared load balancer. One of the things that is most expensive on AWS are the load balancers. So I went the full Monty and implemented the load balancer. And so I have my multiple microservices running off of one shared load balancer, which reduces the costs. Super fun, super interesting. Again, using the model where Beanstalk and Lambda are replicating those. So all this hocus pocus is expensive. There's definitely a lot of cheaper ways to do this. Certainly a lot of fun. Big win is modularity and growth, and a big thank you to Adam Link for saving me a bunch of money on this in AWS. So I know we're running out of time, so I went through that fast. Is there anything that people want me to go into more detail? CloudFront, shared load balancers, API gateway?
Any questions about that?
I'm still like curious about what were like the biggest lifts of each of these going through it. And also, like, if you didn't have a bunch of AWS credits, what do you think your infrastructure would cost? What do you think it would cost when you were fully serverless versus fully elastic Beanstalk? And what is it currently with the hybrid?
I'm running at like $3 or $4 a day, which is ridiculous. And again, thank you, Adam Link, for for making that possible. I mean, honestly, like I would probably be building all of my microservices into one deployable. So I'd keep the software lines in place, and I just have one deployable and one Beanstalk instance running. So I'd probably cut that cost in a third. Honestly, the lambdas are effectively free at this point. Like I'm not getting enough traffic. It's just dev and staging. So it's all kind of falling into the free tier. So it's really just the production that costs anything at all. And running, you know, I'm running 3 or 4 Beanstalk deployments for each microservice, again, which I wouldn't do if it wasn't effectively free. And I'd probably just keep the software lines strict and roll them into one deployment. And then I'd be into the $1 a day type cost range at this point, which is still, I mean, it's kind of silly talking about that kind of money, but it adds up.
Well, when you're early stage pre-revenue, it adds up for sure. What is the cost of the load balancer? Last time I had looked into those, they were quite expensive. That would be like the major cost in the stack.
Yeah, it cuts your with 4 Beanstalk instances, it basically it saves probably, I want to say 75 cents a day on each instance.
Okay.
Yeah, it's not crazy amounts of money, but it adds up, especially when you start. Every time you deploy a Beanstalk instance, you have to pay for a whole new load balancer and all that. I don't know. The shared load balancer is nice, but it's a pain to manage. Like it's, I don't know if anyone's done. I mean, I don't know. We used to build our own load balancers and failover clusters and all that kind of stuff. So I'm familiar with how all that works, and so it's actually kind of fun playing with all these little toys that Amazon gives you. But if you don't know networking and you've never built a failover cluster, then I wouldn't go near
Noted.
it. Yeah.
All
The
right.
heavy lift is a lot of networking. You spend a lot of time trying to save, figure out how to configure things to give yourself flexibility. And at some point, the whole monolithic architecture becomes attractive. But depends where your skills are and what you're comfortable doing.
That's one of the interesting things for me is that, like, I've worked on several projects now that attempt to use more modern paradigms. But if you're just trying to spin something up, right? And this is like, I don't know how many generations apart you and I are, right? Going back to the HTML chat, but it's like, right, I'm now part of the generation where I'm talking about Ruby on Rails and everybody just kind of scoffs at you, right? Like, hopefully at some point in like 10 years, it'll be vintage and it's cool. And I can like find it in a box and wear it like old jeans. But like right now it's in that, like, that old, you're not cool anymore phase, but it's so fast to spin up a Rails application and deploy it and have everything ready to go. And when you're going to a lot of this newer stuff, it's like, yeah, it's really cool and it can save you a lot of money and handle really high volumes of traffic. But it seems like in a lot of cases, like, you can spend so much time down there in AWS land and setting up these new configurations and paradigms that, like, you wouldn't get the business to the point that it would matter,
It's a very good observation. I mean, I'm working with a client in Portland right now that, so in full disclosure, part of the motivation to me doing this was expanding my tool set for my consulting business. And quite honestly, knowing how to do some of this stuff on AWS was a gap for me. So part of this was a learning curve for me. And I don't know that I would have done, I didn't do this for Music Nest. I did this partly to learn how some of this stuff worked. The two motivations for me are, like when I look at this client in Portland and the way they need to deploy across regions and staging and all this kind of stuff, I'm like light years ahead of them. And I'm in a position where I can really give them good advice on how to structure this to be manageable. Because the minute you start talking about security and which instances have access to which resources, once you roll that into a CloudFormation structure, all that's done, and your infrastructure is code, and the relationship between your underlying data tables and your queues are all defined in your stack. And then all of a sudden you have to roll out production and you don't have to worry. So I think, there's a line that's not very far down the road where this stuff really pays off. The other thing is, I think from a software perspective, I don't really, microservices are great, but microservices and separate deployments aren't mutually exclusive. You can build a monolithic deployment and maintain hard software lines and accomplish the same goal. And I think that's the most reasonable compromise, is like, what you don't want to do is build your software to a point where all of a sudden all your components are dependent on each other, and when some library updates and it's not compatible with this version of that, then you're stuck. I ran into that problem with my auth, where the library I was using for authentication was not compatible with an AWS upgrade that I needed, so I had to split them off, and it was easy.
Gotcha. That's really interesting, right? Because as we're talking about this, I'm thinking back to, when I decided I needed to learn proper deploy methodology. So in the Rails world, that was Capistrano, right? And this is circa 2012, monolithic app. You have to set up your load balancer. You have to set up your application server. And it was quite a big lift, right? I mean, I had to learn like a lot of new paradigms to do that. I never got to a point where I was clustering or anything, but I think that's one of the interesting pieces that I'm coming full circle on, is that, there's a lot of talk about, everything needs to be microservices. And now it's like, well, no, like in a lot of cases, things get way too complicated and observability becomes a problem in tracing. but I am starting to see a lot of benefit from hybrid almost across the board. So even within Legalverse and what we're doing, we've got stuff that's written in Go. We have stuff that's written in Ruby. We have stuff that's Lambda functions that are processing in the background. And in a lot of cases, like, we don't have choices in the libraries that we're using. We have to use what's available. And Avi and I have been having a side chat about a lot of what you've been talking about. And what's interesting to me is that I feel like a lot of the glue that makes this possible nowadays is the fact that we're getting away from server-side rendering of HTML and CSS and JavaScript. And it's like, as soon as you start going down that path of having a front end that just needs to talk to an API with some protocol, all of a sudden you now have that flexibility. And that was something that to me has been like the largest change of the last 6 months, is all of a sudden while I didn't really want to take the time to learn React and Angular and all these front ends, and I was more concerned about just sort of getting stuff out the door and making it work, it was like, there's a huge burden that you're able to get rid of by switching to APIs, right? All of your backend services become infinitely easier to test if you're just sending data back and forth. Your front end actually becomes easier to test because you can fake the backend data coming back and forth and verify what's happening. What have been your experiences with that and going to Angular and setting stuff up as microservices?
So again, testability is the biggest part for me. I mean, in a dumb, simple situation like Music Nest, there's still enough moving parts that I don't have time to test that I haven't broken anything dumb with this release when I do this release. So having those things broken apart just gives me the peace of mind to know that I'm not breaking the auth. The JSON library is not going to conflict with this deployment because they're separate. So when I deploy stuff, I know that I just have to test as one piece. And so from a peace of mind, I'm very stringent on my unit testing and all that kind of stuff. But you never know until you deploy something if the plumbing's all going to line up. And so limiting the amount of plumbing you have to worry about when you deploy something is a huge gain for me, and it gives me peace of mind. I don't have to worry. So that's one thing that you mentioned. Testability is a huge piece of it. I mean, I don't know, like, microservices is definitely an abused term. Like I said, for me, it's just, I think of it as, coming up with those subsystems that allow you to think about them independently so you can change one without affecting the others. And I don't know, that's just how I've always thought of problems. But again, there's definitely some overlap for me in terms of my consulting world where the problems and the budgets are larger that kind of warrant those kind of well-baked architectures and testabilities. I guess the one thing I wanted to say was that so the slide I put up here, Cloudfront really can do a lot of this for you. I learned about this thing called Lambda Edge. Has anyone heard of that? So Cloudfront, you have origins, right? So you put a resource underneath your distribution, and then you say, this points to my API or this points to my S3 bucket. Well, you have the ability to write a Lambda that basically intercepts those requests to and from the origin, right? So your origin would be like your API or your S3 bucket for your resources. And basically you can take anything that you've built for something else and repurpose it in a package for a specific consumer in Cloudfront. It's pretty amazing. And there's these things called Lambda Edge that allow you to write code that augments the response and request back and forth to the server. So you can repackage services and resources in a way that a specific piece needs them. To answer your question directly, Jeff, this was the one piece that I think is most powerful on the AWS stack that you probably couldn't live without, because it really gives you ultimate flexibility in terms of controlling how you deploy something. I don't know. I had a lot of fun with Cloudfront.
Can you add some more context to that? Like, I don't know that I fully understood what the example is showing.
Yeah. it's not a very detailed example. So you have, when you think about your API, your challenge is to aggregate your services in a kind of cohesive way, right? When you're deploying an application, your challenge is to aggregate resources for the application in a way that makes sense to the application. So my listener app needs access to a different set of things, but similar than my studio app. So Cloudfront, in your Cloudfront distributions, you can basically create your API, your resources, and then your application can think of them just as subdirectories effectively. So it lets you repackage whatever you want to give in a way that your app doesn't have to worry about it and go to 5 different endpoints. So it keeps your app nice and simple, but it still allows you to kind of have your back end a little bit more complex. I can show you an example, but it's probably, I'd have to probably dig out the AWS control panel and all that kind of stuff. And I sense we're past the time frame for that. But Cloudfront distributions, cool stuff. Origins, behaviors, caching, all that kind of stuff. It's pretty awesome. And I think that's the one place where I'd say, the two worlds meet, Jeff, where you have the ability to repackage, but yet keep things simple on the front end, which is kind of where you were going, which is the goal.
Yeah. So is that how you're handling, say, routing to stage versus prod for those APIs? Is that what you're using that for?
Yeah, sort of. So my application has, here, let me just show you. Hold on. You beat me to it, Jeff. I got to show you the deployment. Let me see if I can get in here quickly. No. So here are all my deployments that I have for the application. So here's my staging app. Here's my production app, right? And when I go into this deployment, underneath this, we have origins. So this is my API, which is a redirection to the prod v1 instance of my service, my API. This is a pointer to the production audio resources. So from an app perspective, the app just knows about two things: an API directory, and then actually let me show you a different example. I'm sorry. No, that's not what I want. So the listener, right, has an API, has resources. The resources just point to an S3 bucket. So from a app standpoint, when the listener loads and it needs to load an audio asset, it just uses everything in the resources subpath. And so Cloudfront just basically packages that up as part of the same domain for that app. When it calls the API, it basically just points out to the production version of my service in my API. In staging, which is this is the staging deployment, everything's the same except it points to staging. So it allows me to deploy the same artifacts and have different services in the back end without changing anything, basically. So this is effectively my staging site versus my production site. The code is all the same. The front end code is exactly the same regardless of staging or production. And so I use Cloudfront to aggregate that, but I use API Gateway to kind of aggregate the different versions of the API. So it's overkill. I'll admit that. I can say that out loud. But it works great once it's all set up. And part of this was me and the learning curve of figuring out how the technology works. So Cloudfront is the level that I think is probably worth a little more investment because it really just lets you package stuff. And like this behavior, for example, if we go in and look at this behavior, every time a request is made, I execute a lambda, and every time the response is made, I execute another lambda just to massage the data to be what the client needs. So you have a lot of control over how you're serving things up, and you can make kind of real similar things subtle but easy to use for your front end. And the goal is to keep your front end client dumb. Yeah, does that help?
Yeah, it does. It does. Yeah, I'm using the 2012 version, which is that I pass an environment variable when I compile the assets and push them. But this is way cooler.
Yeah, I don't know. It's cooler. It's different.
Well, it's also that like when you create a new API gateway, right, that URL is going to change slightly. So in your case, it makes sense to have a dynamic version.
Yes.
Right.
Yeah.
Like you wouldn't know you wouldn't know necessarily, like if you did a deploy from scratch, you wouldn't know what the URL for that API endpoint would be yet.
Yeah. And it eliminates cores as well, which is nice.
Oh, cool.
Yeah.
That's
so it gets rid of the whole cores problem just off the face of the earth, which makes me happy. So there's a few advantages to it. But yeah, it's a different way of skinning.
Well, I've literally spent 12 to 14 hours on that alone. So
yeah, no, core sucks. I hate cores.
Yeah.
Like yeah, it's I actually think that was the reason I ended up going there, because I got tired of always screwing it up. And then it was even more fun is you check the caching bit, and now your options request is cached. And so things that were failing because you ran against it in development, because it cached the version of your development, crazy stuff.
Yeah.
So this just gets rid of that whole problem. Just different ways of skinning a cat.
Yeah.
But it's really, I mean, AWS it's amazing. Like I think about what I was able to do here, and I mean, I had teams of people building this stuff out when I started doing this. Like it's amazing what one idiot in his office can do today compared to what like a whole team of idiots it took back in the day. It's amazing. So, yeah, fun stuff.
Yeah.
Any other questions before we close it out this evening?
I love your Thanksgiving little picture there.
Yeah, Adam, you're right. Lambda Edge has really securing. You can use it. I mean, talk a little bit about that, Adam. I mean, it sounds like you've used Lambda Edge. I'd love to hear your thoughts as well.
Yeah, I'll go briefly here. I've used Lambda Edge multiple times to rewrite headers on responses to add content security policies. That was actually one of the major things that we used it for. Was we had a common Lambda Edge that we deploy out to multiple Cloudfront distributions as a way to secure our site from being embedded. And I've even gone as far as you can introspect the body of the request coming back. So essentially it is an AWS provided man in the middle route, but like, a white hat man in the middle. So you can basically modify page content and stuff like that as well.
Have you had any cost issues? Have you run into any cost issues with Lambda Edge?
Without sounding like a jerk, we never looked at $1 a day as being a cost issue when we were using Lambda Edge. Sure. So yeah, no is the answer, but we were also in the 4 to 5 to 6 figure a month range.
Sure.
For AWS.
That's a great answer. Yeah, I normally don't worry about $1 a day, but part of it's the intellectual challenge of making sure that that $1 a day is not going to change to $5 a day, to $6 a day, to $10 a day if I do something totally stupid. So, good answer. Thank you. That helps me.
All right. Well, with that, I think we'll call it an evening. Feel free to maintain the conversations in Slack. This was super fascinating tonight, Dave. Thank you so much for presenting for us. Next month, I believe we're going to be taking a break for the holiday. Stay tuned on that. But then in January, we're going to have Asad Faizi talking about deployments of Kubernetes and managing those. So looking very forward to that. Thank you all for coming tonight, and look forward to seeing you on Slack and in the new year.
Thanks, Bradley. Thanks for presenting, Dave. It was good stuff.